Okay, so we're working on number 2 on this practice test, and it talks about this hill that's at a 30-degree angle from the horizontal, and there's a wooden crate on it, and that wooden crate has a mass of 25 kilograms. Okay, because I know the mass, I know the force of gravity on that mass, okay, because the force of gravity is just mass times acceleration due to gravity, which is 9.8 meters per second per second. So we do 25 times 9.8, and you find the force of gravity, which is 245 newtons. So that's going to go here, 245 newtons. All right, what else do we know? It says an additional force of 59 newtons must be applied to the crate perpendicular to the surface to hold the crate in place. All right, so I'm going to show that force in purple. Okay, and that's pointing down, okay, into the surface of 59 newtons. And then because there's a surface, we know that there's going to be a normal force. Okay, anytime something's sitting on a surface, there's a normal force. And then it's, let's see, it says the crate is being held in place. So there's a friction force. It tells us the coefficient of static friction, anyways, is going in the left direction or up the hill. It opposes the motion of this crate. Okay, so I'm going to draw some axes here, x and y axis. If you notice the normal force, the 59 Newton force, the force of friction, they're all forces that act along either the x-axis or the y-axis. Force of friction acts in the negative x direction. The applied force of 59 newtons acts in the negative y, normal force positive y. And then you have this rogue force here, the force of gravity, which is in neither the x nor the y direction. Okay, so how do we deal with that 245? Well, if this is the x direction and this is the y direction, we know something about it. We know that the angle here is 38. And so we can divide this into some components. That 245 newtons points down, okay, down in the y direction and to the right. So there are components. One of the components is down, one of the components is right. In the downward direction, so that's the gravity in the y direction, and then the gravity in the x direction. Okay. So we're going to split that up so that we can replace this force on our free body diagram with its components. We want the ones that act on the x and y axis. So I'm going to write those things out here. Force of gravity in the y direction. Okay. We know that cosine of an angle is equal to the adjacent side, which is the g of force of gravity in the y direction, over the hypotenuse, which means that the force of gravity in the y direction is just Fg cosine of the angle, or, oops, I know the force of gravity. So 245 cosine of 38, and I know the force of gravity in the x is 245, but this time, since it's opposite from the angle, we're going to use sine of 38. And I'll find those real quick. So we got 193 and 150.8. So I'm going to draw those on here. 150.8, that's in the x direction. And then pointing downwards, we've got 193. And watch this, very important. Okay, this is a portion of the force of gravity. This is a portion of the force of gravity. Okay, so I don't need the rest of gravity. I don't need the whole of gravity that doesn't act on the x or y axis. I just need the components now. All right, the thing that it asks us for is the force of friction. And so the force of friction is in the x direction, so that's where I'm going to start. The sum of the forces in the x direction is equal to m times a. It says that the crate is being held in place, which means that the acceleration of the crate is 0. So actually, the sum of the forces in the x, they still add up to ma. Ma just happens to be 0, which makes life a lot easier. So then we're going to divide this into positive forces and negative forces. In the positive direction, we have that 150.8 newtons. In the negative direction, we have the force of friction, which means that the force of friction is just 150.8 because there is no acceleration, or you could say 151 to account for significant digits. And that's all you have to do for that one.